Hello everyone, my name is Kiran Rao. I am going to deliver a presentation on introductions on supercapacitor. So in supercapacitor, I will discuss about the introductions of supercapacitor, comparison between supercapacitor versus battery, working principle of supercapacitor, classification of supercapacitor, advantages, limitations and applications of supercapacitor. So here first we are going to discuss about the introductions of supercapacitor. The supercapacitor is an energy storage device that has one specific property that makes it an interesting component in some applications. This property is its high power density that enables it to handle fast fluctuation in energy level. So supercapacitor basically is nothing but an ordinary capacitor but having a capacity, supercapacity. So the supercapacitors perform midway between conventional capacitor and electrochemical cells. Supercapacitor is an electrochemical device consisting of two porous electrodes immersed in an electrolyte solution that stores charge electrostatically. And the features of supercapacitors is high energy density. It has a high power density, high capacitance and its longer life. So this picture which will be shows the representations of supercapacitor having a voltage is 2.7 volt and 3000 farad. So this will be the supercapacitor. In ordinary capacitors having value which is in microfarad, most probably in ceiling fan we use 2.5 microfarad capacitor. So basically ordinary capacitor which is used for energy storage device. Supercapacitor having its characteristics, the names indicate having super, so something super which is available in the supercapacitor. So in next slide we will discuss about the comparison between the supercapacitor versus battery. Basically battery also energy storage device which is most probably used in inverter, bikes. So if while comparing with supercapacitor, charge and discharge time in supercapacitor which is varies from 0.3 to 30 seconds, and while comparing with the battery it varies 0.5 to 10 hours. Basically to charge the battery near about required 6 to 7 hours or more than 7 hours. And if I am considering the energy which is watt hour per kg which is varies from 1 to 10 for the supercapacitor and battery which is 8 to 700. Then important parameter we considered the cycle life the cycle life which is varies, means which is greater than 5 millilens, while in battery the cycle life is less than 1500. So while comparing with, we observe that the life of battery which is very less as compared to the supercapacitor. Then charge discharge efficiency which is also high in case of supercapacitor as compared to the battery, and specific power which is in watt per kg which is less than 10,000, and in battery which is less than 1000. So basically supercapacitor which is used for charging purpose to store the energy. Then working principle of supercapacitor. So the ordinary capacitor having two parallel plate and one dielectric material. But in case of supercapacitor considered, there are two cases. First one is uncharged conditions, second one is charged condition. So in this case there are two parallel plates which will be considered, and we use the material. The material, it may be is your carbon materials, it may be graphenes, carbon nanotubes we generally used. Here the orange circle shows the positive ion, so this will be the positive ion, and blue circle which will be considered as a negative ion, so this will be your negative ion, and dotted line which will be shows dielectric material, as similar to is your ordinary capacitor. So when the supercapacitor is charged, this will be the uncharged conditions. When the supercapacitor is charged, the electron at the cathode attract the positive ion. So electron at the cathode, so this will be your anode, this will be your cathode. So here the electrons at the cathode attract the positive ion. On the anode, the vacancies of an electrons attract the negative ions in order to locally obtain the charge balance. This attractions of ion leads to a capacitance being formed between the ions and the surface of the electrodes. So here which will be represented, this will be the charge conditions. In uncharged conditions, the ions which will be shown here, and while applying in charged conditions, the positive ions which will be in orange circle which will be nearer to this plate, and blue circle is nothing but the negative ion which will be attracts towards the positive, and this will be considered as charge conditions, and we store the energy in the form of charge conditions. Classifications of supercapacitor. Supercapacitor having classified into two categories. First, double layer capacitor. Second, pseudo capacitor. Depending upon the material used in the supercapacitor, again double layer capacitor having activated carbon type and carbon aerogates, and some of the time we use the material like, as I have already said, carbon nanotubes, graphene, carbide derived carbon. So in case of pseudocapacitor, we generally use the polymer and metal oxide as a material. And we combine both double layer capacitor and pseudocapacitor. It becomes a hybrid capacitor. Charge storage electrostatically and electrochemically. Basically, double layer capacitor, which store the charge electrostatically, and pseudocapacitor, which store the charge electrochemically, and we combine both capacitor and it became your hybrid capacitor. Advantage point of view. So as we already discussed about the features of supercapacitor, and according to that, having an unlimited cycle which is greater than 5 millions or which will be more than 1 millions. It has a high specific power. It is charged in seconds. While considering the battery, it requires the 7 to 8 hours for charging. Similarly, while charge the supercapacitors, which is a fraction of second, we can say that it will be charged the capacitor. It has a simple charging. It is safe and excellent low temperature charge and discharge performance. Then limitations. One of the biggest disadvantage of supercapacitor is low specific energy. Then again, it will be discharged quickly. Voltage across the cell which is low, and cost per watt which is high. A linear discharge voltage prevents using the full energy spectrum. These are the limitations of supercapacitor. So applications point of view, which is used in various applications, like in power sector we generally used, energy storage we generally used, memory backups and power supply. Basically, in case of power, we generally used some of the time supercapacitor which is used for starting purpose of hybrid electric vehicle for running purpose. Similarly, solar plus wind combined together along with your supercapacitor. And one of the example, in electric bike we generally used this supercapacitor. Energy storage device, if I am considering the watch, mic, remote, we generally use the supercapacitor for small applications. Similarly, memory backup if required in cameras, we generally used mobile, we generally use the supercapacitor. Thank you.